Okay, I guess we're live. Hello, welcome everyone. And today I wanted to actually start working on a programming language, and I'm planning to call the language ICE. So, the reason I'm going to be streaming this is because. Sorry, one second. So, the reason I'm going to be streaming this is because I want to have some motivation and some uh, accountability to complete the language, because I really want to complete this language, but most of the times when I've tried to write a language before, I've always stopped midway and never completed it all the way, right? So let's quickly take a look at how we're going to make it, right? So the goal of this language is uh, to be an experimental programming language which is unsafe, C like, and I want to test linear types in an unsafe language. So, if you've ever used Rust or Mojo, you might be familiar with how linear types work, but essentially they give you a sense of uh, uh, what do you call that? Security, I guess, maybe robustness to your type system. So I do want to add support for linear types eventually. But first, I guess we have to make the actual programming language, right? And this is the roadmap that I have decided to consider the language mature enough to be maybe version 1, right? So I do want to start uh, with basic expressions. So on the right hand side here, you can see that this is just a basic expression, and I want to add support for being able to tokenize this, parse this, convert it into an IR, then do type checking and so on the IR, and then finally generate assembly code out of this. And the compiler will be written completely from scratch, which means I do not plan to use any external libraries. Everything will be done with just the standard library provided by Rust. And then, uh, as for the generation of executables, we will use the native assemblers and native linkers present in the operating systems. I guess I should also explain that we will be initially only supporting Mac OS ARM64, and this is because I I own an ARM64 Mac OS, right? So initially I'll be only supporting uh, this device, and then maybe in the future, once we have more, uh, we have a better use of the language, I can go ahead and support x86 64, Windows and Linux as well. Right. So uh, in this stream, I want to try and check this to do of the roadmap, right? So on the right hand side, you can see this is what we are trying to compile. So let's start out, right? Since I've written this multiple times before, so I'm just gonna quickly run through the tokenization and the parser, and then we can move on to the IR generation and then code generation phase, right? So I'm going to be dividing up my project into a front end, right? And front end essentially will have a tokenizer. It will also have the token, so it'll tell me what tokens are, and we'll just do a mod.rs, right? So in here what we'll say is 1 second. Right, so here what we'll say is mod tokenizer and mod token, and we can also go to main and we'll mod front end. What was this? I got this computer screen and audio. Deny. Never mind, you don't need it. Right, so let's start with the basic stuff, right? So first what we need to do is actually read the file, right? So let's get the arguments. So let file name is args dot skip1 dot next, and what we can do is simply say sum, else I'm just gonna print line error, please provide a file to compile. Right. Now that we have the file name, what we can do is we will just say front end. So let's go to the front end, right? And here we'll say pubfun generate AST. So we want to generate the abstract syntax tree, and we will take a file name as a string, and we will return something for now. And I guess I'll just make a new file, errors.rs, and we'll say pub front end result of t is result, oh sorry, my bad, type result t with front end error, and pub enum front end error is just could not open file, I guess. Rather just file not found. File not found. And then we can go to mod errors, and we do pub mod errors, and then in here we'll say we want to return a front end result of nothing for now, right? And then now let's actually read the file. So I guess we'll keep that in the tokenizer, right? So let's say let tokens is tokenizer : new, and we'll say file name, and then dot tokenize, and here we want a colon. So now obviously we don't have a tokenizer, and of course we need to do. Right, so now we need a tokenizer. So let's just say pub struct tokenizer, and since I've done this before multiple times, so I'm just gonna breeze through this, right? So we need the characters, which is a vec of char, and we need the index, which is a usize essentially, and we can impl tokenizer, and what I'm going to do is simply says first pub fun new, and we take a file name, that's a string, and we return a front end result of self, and then now we'll say let contents is fs read to string with file name, and I'm not sure what this returns. It returns an IO result of a string, so we'll just dot map error, and we'll just say, well, whatever the error is, I don't care, just map it to front end error file not found, and we'll just do that. My bad. What's the format? Command Shift I. That did not do anything. Okay. So now what we can do is we can just return an okay self. Characters is contents dot chars dot collect, and index is 0. Right. So that's good. And then that should make the tokenizer for us. So mod.rs should be happy with the tokenizer. And now it says we don't know what tokenize does. So before we add the tokenize function, we need to actually define the tokens, right? So we'll say pub struct, let's just go with enum token, right? And then the token is, so what tokens do we need, right? So we need a literal, that's a string. We need a plus, we need a minus, I do want a minus, and we need a star. I guess we can go for slash as well for division, right? So this is a plus, right? This is a minus, this is a star, and this is a slash, and this is just a literal. I guess what I can say is num literal, right? So these are the tokens that we're going to use, and we can go to tokenizer, and we'll just say that we have a pub function tokenize that takes a mutable self and returns a front end result of a vec of tokens, and we'll just say let mute tokens is vec new, and we'll just say tokens. My bad. So right, so now obviously we don't know what that is, so I can just do import token, right? And then now we know what tokens are, right? Now, right, of course, so we need to exit one. And then we can say let AST is front end : generate AST from file name, and I guess we'll handle with the result, the errors later, right? So tokenizer needs to tokenize stuff, and these are the tokens. Here we tokenize, we get the tokens, and these are the errors. So I'm just gonna add another one, say invalid character, and we'll just say ch is char, right? Because we're gonna need this. So let's quickly go into tokenizer, and we'll add some functions that we need. So we need a function peek on self, and we just simply return self dot chars dot get index self dot index. Now of course we need to say option of char, and I guess I need to do dot copied, right? Right, so this gives us peek and function skip, which is self. It does not return anything, and we just do self.index +1. So we need, of course, so we need to be able to skip to the next character, and we need to be able to peek the current character, right? So quickly, let's just start working on it. So I let some character is self.peek, so we get, as long as we still have a character to check, we'll just match on the character. And what I'm going to say is x if x dot is ASCII digit. So if it is a digit, then we are probably trying to tokenize a number, right? So here what I'm going to say is probably a number, literal, and then also if it's a plus, then I need to tokenize, create a token. So we can just do tokens dot push token plus, and then if we have a minus, then we're trying to tokenize the minus, so we can just do tokens dot push token minus. If it's a star, then we can just say tokens dot push token star, and if it's a slash, then we'll just say tokens dot push token slash. With this we should have that part, and if we do encounter anything else, then we probably need to just say return error, print an error, invalid character ch, right? And we also need to have another one, x if x dot is ASCII white space, right? If it's a white space, then we just want to self.skip it. And now we just need to tokenize a number literal. So let's put that into a separate function. So function tokenize number literal, it takes a mutable self, and we return a token, right? So what we're going to do is let mute string, or rather number, is string new, right? Now while let some character ch is self.peak, right? And I'm just gonna, if ch dot is ASCII digit, then I wanna do number dot push the character and self dot skip the character, and else I wanna, what do I want to do? Otherwise I just want to break, right? So I don't want to do anything. And down here I'm just gonna return a token number literal with number, and that should tokenize the number for us, hopefully. And we can go in here and we'll just say tokens dot push self dot tokenize number literal, and this should tokenize the number for us. So let's go and check, take a look at what's going on. Sorry, let's take a look at mod.rs, right? And we can just do print line and tokens, and let's pretty print it. So now I'll say tokens is not debuggable, so let's just quickly debug it, derive debug. So we'll say derive debug, right? And then hopefully mod should get fixed. What's the error? Front-end error does not implement debug, right? Of course. So I guess we can just do that, right? And that should give us the tokens. So let's try it out. So cargo run, and we'll give, let's just try to run normally, right? And I'll say hello Ice programming language error, please provide a file to compile, right? Before I do that, I actually want to make some changes in here, right? Let me just remember how to do this, right? Sorry. So here I want to say lints.rust, and I want to say allow. So I just don't want to get those errors in here, right? Warnings. So that's good, right? So it says error, please provide a file to compile. So we can just do cargo run./tests and expression.ice, which is this file right here, of course. So we go into an infinite loop. Now why do we go into an infinite loop, right? So let's just quickly take a look. So if it is an ASCII, right, of course. So here we need to do self.skip and self.skip and self.skip and self.skip. So let's try it out again. Right, so not implemented, but that's fine because we do get the correct literals, correct tokens, right? So now we have essentially tokenized this into a number literal, which is 35. Then we get plus, then we get 17, then we get a star, and then we get 2, right? That's pretty good. Now the tokenizer is done. We need to actually parse it into an expression, right? So let's quickly make an AST.rs. Right, here's where we will define our abstract syntax tree definition. Right, so for now we just want an expression. So I'll just say pub enum expression, or rather we'll be more specific. So an AST expression is, it can either be a number literal, right, and the value is string, or it can be a binary expression in which we have an LHS, which is a box of AST expression, right, and the operation, which is a token for now, and the RHS, which is also a box of AST expression, right? So the reason we need to have LHS and RHS be box of an AST expression is because you cannot have recursive dependency in a structure, which means essentially, like, if I have a structure or an enum called AST expression, then I cannot have a field inside it which also refers to itself. So that's why you need to box it, right? And then I guess this is it for now, right? We just need this. And then we can go to a parser. So let's make a parser. Right. And let me just quickly go into mod.rs, and I'm just gonna pub mod the AST and also mod the parser. Also, token needs to be public, just in case we need access to it somewhere, right? So now, how do we want the parser to work, right? So we can say let AST is parser new from tokens, right? And then dot parse. So parse, we'll do the failing case later, and we can change this to be the AST, and we can say okay, right? So now AST should be of type AST should be of type AST expression, I guess, for now, right? So I'm just going to say parse expression, right? So let's quickly go ahead and make our parser. So pub struct parser, right? So we need the tokens, which is just a vec of token, and we also need the index, which is usize, right? Now, of course, we don't know what token is, so let's just import it. And now let's do impl parser, and we're just going to do pub fun new, and we're going to take tokens, which is a vec of token, and we're going to return self. So that's just self tokens and 0. So that's good. What's going on? Please stop. Sure. Right, so now let me just take a quick look at how I had done that previously. Parser. Right, what do we have? I use, right, okay. So we do want a function called parse expression. So parse expression, and we're just going to take a mutable self, and we're going to return an est expression, and we'll just keep it a to do for now. Now we also do need some helper functions, so we can do function peek on self, and we return an option of a reference to a token, and we can just do self dot tokens dot get at self dot index. Then we also need skip, so function skip on mutable self, and it just does self dot index +1, and we need a function expect, because I really like this function. I've written it multiple times before in all of my previous implementations of the languages, right? So it just says that we expect a kind that's a token kind, right? And now obviously we can return a front-end result of a token, and let's just leave it to do for now, because I need to implement token kind, right? So over here we're going to change this to token kind. So and let's make a pub struct token be kind, token kind, and a value be an option string, right? And we can just say derive debug. Now something breaks up here, so it says token unknown. Let's import that. All good. Mod rs is broken because of that. Sure, we can just get it. I should fix that. Parser is broken because we still need to fix it. And right here, so we can just do oh, of course. So this is a token with kind being token kind slash and value being none. Now what's happening here? Field is private, so let's just make it public. Right, let's go to tokenizer. That fixes that. So what I'm going to do is I'm going to say insert token kind is this thing, word insert, and I'm going to say comma and value is none, and we can stop recording. And now can just, how do you, oh. Okay, I guess macros are pretty useful, right? And of course here it's gonna be token with kind is token kind number literal, and the value is some number, right? So that's good, that fixes these errors. Now we can go back to the parser and implement this, right? So what I'm going to do is first if let some token is self.peak, right? So if we have some token, then we do if token dot kind is kind. That means we found the correct token. So I can just do let return value is okay of token dot to owned, and we can do self dot skip, and we can just return red. Otherwise, if it was not that, then we can just return an error saying front end error, saying expected token, and we'll say expected token dot kind found token dot kind, sorry, my bad. And we can just do that, right? And over here we can say else, we can just return an error saying front end error unexpected EOF, right? So now obviously what's going on? Okay, either way, let's just say expected token expected is a token kind, and found is a token kind, and we can say unexpected end of file. Now let's quickly go back here and let's just say import token kind. Now obviously we need equals partial equals, my bad, partial equal, right? So now we can just go back to here, so we can do that, and of course, so I need to actually allow copy here, so clone copy, and I need to clone. Now if we go to parser, it should be fine. We are cloning it, but yeah, it's all right. So these are essentially the helper functions that we need to parse an expression. Now let's try and parse the actual expression, right? So I do not actually know what this is called, the method I'm using for parsing the expressions, but I remember reading about it somewhere, and I've just been using the same method every single time because it works really well. So what I'm gonna do is simply say function get atom, right, on mutable self, and it's gonna return a front-end result of an AST expression itself, right? So we're gonna say let token is self.peak and dot okr, and we'll say front-end result unexpected, not front-end result, front-end error unexpected in the file. So now that we have the token, we'll match on the token.kind and we'll simply say if it is a number literal, right, then what I want to say is I really don't like this auto formatting of Z, but whatever. Let some token be equal to self expect expect token kind non-literal. We can just return it out, and this should give us expect gives us result, right? So this is going to be okay. This is going to give me the token directly, and we can say let expression is AST expression of number literal with value being token.value dot unwrap, and we can just return an okay of expression. And if we have anything else to do, add an error for this, right? So for now, this is what we have. We have the get atom implemented for the basic need that we have, and now we can go ahead and implement our parse expression. But before we actually parse expression, we need to implement another function called get operator precedence on a token does not have to be that, and we'll just match on token.kind, and what we will say is if it is token kind plus, I'm actually gonna go ahead and say use token kind star. So if it's plus or minus, then I want to return 9, and if it's star or slash, I want to return 10, and otherwise it should be unreachable. Right. And of course we need to return a, I think U8 should be good enough. My bad. Right. So now I guess we can start with this thing. Actually, I'm just gonna change it to an i32 because it's easier this way. Now we say let mute LHS is equal to self.getAtom, of course, and then what we will say is while let some token is self.peak. I'm going to say if not is binary op on token. So we do need to implement this as well, right? So we'll do function is binary op on token, and this is essentially just gonna be use token kind star, and we can just match on token dot kind, and again we can just do plus or minus or star or slash, return true, and anything else we return false. And of course here I need to say it returns bool, right? So we can go up here and we can say LHS, and we will say if it is not a binary operator, then we can just break. Now we can say let operator precedence is self get operator precedence on this token, and we'll say if operator precedence, here we need to A, D, and C is an i32, so we need to accept that as well. And we can say if the precedence is actually less than the precedence that was passed in, then we can simply break out, right? Otherwise, what we'll do is let token is token dot to owned, and we can self dot skip the current token, and then we can say let right hand side is self dot parse expression with precedence is the operator precedence plus 1, right? And of course we don't just return an AST expression, we return a front end result of this, right? So RHS will do that, and then we can just say LHS is an AST expression binary with LHS being LHS, the operator, sorry, we can't do that because we need box new LHS. the operator being the token, and the RHS being box new RHS, and I hope that's fine. And here we just need to return OK of that, and this should now be done with passing our expression correctly, right? And now if we go to mod, so now obviously pass expression returns an error, so we can just put that out, and here we need to give it an initial precedence, so we'll just give it -1, and now AST should be an AST expression. Now I'm just gonna do this, and let's go to main where we generate AST. So this should be something. So what I'm gonna do is match AST, right? So if it's okay AST, then I just wanna actually what I'm gonna do is say okay AST, and I'm gonna say else. We can't do that because I need to know the error. So we can just say match on this, right? And we'll say okay value. I just want to return the value. Otherwise, if there was an error, we'll just say do neatly print errors, right? And we can just do print line, and we'll print the AST in a pretty print manner. And obviously AST does not implement debug, so we will oops, what did I do? Right, we'll neatly derive debug, and that should do it. So this should hopefully get the front end done. Now if I run this, it gives me the expressions. So we have LHS is 35, the operation is plus, and the RHS is actually 17 times 2. So we have successfully actually passed this expression correctly. So that 17 times 2 happens first, and then we add 35 to it. So it goes in the BODMAS rule as expected. Right. So this was our front end. Now we do need to do the back end, right? Okay. So how is backend going to be done? Backend is going to give us an intermediate representation, right? So this thing will essentially take the AST, convert it to an intermediate representation, do type checking and control flow checks and all those checks on the IR itself, and it will just return the IR, or it will return us an error. And then the next step is to do code gen, in which we pass the IR to the code gen, and then the code gen will actually convert the IR into a into an assembly file, right? Yeah. Okay. Either way, for now, I'm just gonna do done front end, added compiler front end, yes. And now, I guess what I'm gonna do is continue this tomorrow. For today, we have done a good amount where we have an expression and we were able to tokenize the expression and also generate an abstract syntax tree of the expression in the correct order, right? So the multiplication happens before the addition. And tomorrow the goal will be to actually work on the back end, which will first generate an intermediate representation for us. And I don't think I want to do type checking right now. We will do type checking a little later, because right now we essentially only have one type, which is a U64, right? And then we can basically work on code gen after intermediate representation is generated, and the code gen will essentially take the IR and convert it to an assembly and write it to a file, I guess. And then we can use the assembler and the linker to link it. So that's the plan for tomorrow. So tomorrow I want to write the IR generation and the code generation for this simple expression, and hopefully it will work. Right. Well then, I guess this is the stream for today. See you guys tomorrow.